Hi guys, in this video we're going to be understanding the fundamental of blocking the event loop in Node.js. Event loop is a process in Node.js that helps us maintain the events. It monitors all the queues, does all the things that makes Node.js very powerful. So let's just dive into the code. So what we're going to be doing here, we're going to be creating a simple Express application, and then we will see how we can block the event loop by doing some CPU intensive processes, and then we're going to be looking into the ways in which we can solve our problem as well. So I'm going to be initializing a simple Node.js project here, and let's just install Express as well, and let's just create a file. Let's just call it blocking.js. So what I'm going to be doing, I'm going to be requiring Express, and I will be starting a server, let's say at port 8080. Then we're going to be registering two routes, uh, route 1, which will be doing some expensive calculation, and another route which just be sending a simple response to the user. Okay, now let's just run them and let's see what actually happens. So nodemon blocking.js. So let's just go to our browser and let's hit our route slash route. Let's just first hit route 2. Uh, so both are routes, so let's just make it route 2 instead. Okay, so now if I just hit the route 2, it is working fine. Now what if I hit the route 1, and let's change it. And you see that it is kind of still loading, and now if we try to load the route 2 as well, it also does not send us the response. So why this is actually happening? Right, this is happening because we are running this expensive calculation in here. Because of this, the event loop is blocked. So this expensive calculation is blocking the event loop. But how it is blocking? So let's just look into a diagram here. So how an event loop looks like. Event loop, you can say that it's a semi-infinite loop uh, that actually exits when we don't have any process or there is nothing in the queue to execute. So then it can exit. Otherwise, it just runs continuously and monitors all the queues. Now, what are queues? Queues are the places where your all callbacks would go, right? So we have timer queues, then we have IO queues, then we have immediate queues, then we have the closed queues. So depending on the process that you are executing, particular callback will go to its respective queue. For example, if you are running a set timeout or a set interval and you have a particular callback, then that particular callback will go to the timer queue. Similarly, if you have any file reading operation, if you are making a API call, if you are using a DNS or any kind of input output operation, then that particular callback will go to the IO queue. Then if you have the set immediate operation, then its callback will go to the immediate queues. And if you have any socket close operation or anything closed, like when we are just closing event close or anything like that, then it will go to the closed queues. Now, this particular thing is what we call as event loop, right? So it just runs in a circle, right? That's what as a loop is. It just takes round and round, and it just monitor all the queues and checks if any callback is ready to execute. And so when it is ready, so what it will do, it will just move that particular callback into something known as call stack. So call stack is the place where the execution context is formed and the things happen. So if we are running any code, console.log, running any operation, anything like that, that actually has to execute in the call stack. This call stack is single threaded as well. Right. So now the problem with this approach is that if we have any operation, if we have any callback, which is doing some expensive calculation, like in the case we are doing here, right? So what will happen? This event loop will wait here for that operation to be over. And in that scenario, all other requests will hamper, right? Because now we don't like this request got hit, okay, and this particular callback got inserted into the event queue, into the prospective IO queue. Now, event loop is busy in executing this callback. So it won't take a chance to just move to this particular queue until unless this process is completely over. So now this particular phenomena is what we call as blocking the event loop. Okay. Now if we can have n number of routes. Let's say I just define three. Just define another route, route 4, and just change them as route 4, route 3, and just call it route 2. Now we can have n number of routes, but somehow if our route 1 is hit first, okay, route 1 is if somehow it hits first, then it will hamper the working of all other routes as well. Okay, but yeah, like let's say like if the request actually comes to another route, route 2 or route 3, then obviously they are not doing any heavy calculations. So they will just send a response back to the user. But that can't be the case, right? We just can't predict that which route will the user be hitting. So that's not the particular solution for this, right? So what is the solution for this scenario? How we can do our expensive calculation as well and also avoid the blockage of event loop as well. So for particularly solving this problem, we have two things we can do. First, we can run a cluster. We can clusterize our Node.js server. And second is we can use child threads or something like that. Right? Basically not child threads, child process basically. So we're going to be looking into both of these scenarios. So first, let's just look into the clustering part. So clustering.js. So Node.js offers us this clustering module internally. It's an inbuilt module, right, that we can use to solve the problem. So what we will do, we will write if cluster.is master. I'm going to be explaining this what I'm writing here, but first just let's write the code. Else here we will spawning our Express server. Okay, so let's just bring our Express server from here. Just copy this whole code from top to bottom and let's just put it here. Okay. Now here, what we're gonna be doing, we will do cluster dot fork. Now let's just understand this code with the diagram, what actually is happening here. So what will happen when our application starts? We have only one master process. Okay, this is the main process, or you can say a master process that will actually start. Now, what we are doing here, right? Let's just put a text here. When we start the app, or let's say when we run, let's say when we execute our Node.js file. Okay, so what will happen? Firstly, we will have this process, this master process we're gonna be having. This is the first and initial Node.js process that would be created. Now, what will happen? We're gonna be checking here that if it's a master process. So yeah, it's a master process. We don't have any other process created by this Node.js file. So what will happen? It will just call the fork method and it will create the worker process. Now this worker process would be another process that would be created by this Node.js script that we run. If you see, we are just calling this cluster.fork here. So this actually is going to be creating this worker process. Now, what will happen? This worker process will start this server. Okay, this whole Node.js server, Node.js Express server will be started in this worker process. started here. Now, the next question comes at how many worker processes can be created. So that actually depends on something which is related to your CPU, that is how many cores your CPU has. So depending on the CPU cores, we can create the number of processes. If we have n CPU cores, then we can actually create n number of worker processes. So let's just do that as well. So what I'm going to be doing, I'm going to be requiring this OS module, which actually gives us the number of CPUs. It actually will include the virtual core and physical cores both, and we're gonna be returning the length. So that basically it will be an array, right? So it would be the length of how many elements that array has. So we will be getting the total CPU, and depending on that this total CPU, we would be creating the processes. So I less than total CPUs, I plus plus, and I just call the cluster.4k. So let's say if we have 4 CPUs, then we're gonna be having 4 worker process created by this master process. So just call it W1, W2, W4, and let's say W3. Now these 4 individual processes would be running on our individual cores that are provided by our CPU. So let's say we have a quad core CPU which have 4 cores. 1, 2, and 3, 4. So let's say we have, so this is our CPU. So if you have a 4 core CPU, or if you have an octa-core CPU, depending on what number of cores your CPU has, the number of processes would be created, and they would be taking up the space on the individual CPUs. So let's say W1 might go in here, W2 might go in here, W3 might go in here, and let's say W4 might go in here. Okay, so now now we had one master process that actually created 4 individual worker processes that are running on our CPUs. Now, let's see what actually is happening when we're going to be running our code. So let's just run it. So node-mon clustering.js. So if you see, I have 336. I have an 2 to 4 to 6 3. I have 8 core CPU. So 8 worker processes have been created on my CPU. And now if you see, this is a important observation here, that this particular code is called 8 times, and we have 8 worker processes listening on port 8080. Now here is a situation that we need to understand, that generally we assume and we say that a single process can run on a single port of your system, but how come 8 process will run on a single port? So what actually is happening underneath? We have this master process which is actually listening on the particular port, that is 8080, and these worker process or these child processes are just the part of that segment, and they are just waiting for the instructions from this master process. So what will happen? A request will come to this master process. So let's say this is our user, and it just makes a request, right? So anything, let's say just requesting route 1. Right? So what will happen? This master process would distribute that request into the individual child process in something known as round robin fashion. This round robin is an algorithm in which the processes or CPU distributes the task to the individual cores, or CPU distributes the threads into the individual cores, right? So this is also adopted by the Node.js to distribute the tasks to the worker processes created by the master process. So let's say our first request is route 1. Now this W1 will be handling that expensive calculation. Our W2 and W3, let's call it W3 and W4. our W1 would be handling this expensive calculation, and W2, W3, and W4 are still empty and waiting for other requests to come. So they can entertain other requests as well. So let's just see it in action here. So server, so let's just hit the route one first. Okay, so it is obviously the blocking operations that is going on and on. I'll just hit the route 2. You see that our route 2 is successfully executed. Similarly, if I try to execute route 3 as well, it gets successfully executed. Similarly, if I execute route 4 as well, it also gets successfully executed. So that means we can handle multiple requests, right, without blocking the event loop. But this is not a sure shot formula for solving this problem. What if you have 1,000 users, right? So let's say every individual core would be, so let's say you have 8 cores, and 8 cores would be occupied. Still, you have 992 requests that would be pending, right, to be entertained by the other cores, right? So that's not how we gonna be solving this situation here. So what is the fundamental and best way to solve this particular problem? So what we're gonna be using, we're gonna be using something known as child process to actually see how we can solve this particular situation here. So what I'm gonna be doing, I'm gonna be creating another file. We just call it child process.js. Okay, so we're gonna be requiring the fork method from child process. So what we will do, we will just execute like a separate process uh, to run our expensive calculation. And once the expensive calculation is over, we will inform our main thread or our main process that this is the result. And then what we can do, we can just send it to the user. So let's just look at it. Before that, what I'm going to be doing, I'm going to be creating a file. Let's just call it expensive calculation.js. And here what I will be putting, I will be putting my expensive calculation. Let's say we are calculating the sum of these numbers, right? And sum equals to sum plus I. Okay. Now let's just go to our child process here, and let's just define our routes. So I would be copying this whole code from here, putting here, and let's just bring the express as well. Okay. So now what I will do, I will, whenever this request will come, let me just remove this part. So this will have the expensive calculation. Okay, so what I will do, I will just create a child process by calling the fork method. And what we will do, we will just pass the underscore turn name slash, we'll just call it expensive calculation.js. Okay, so what will happen when this route one will come, will be hit by the front end? We're going to be forking out a separate process using this fork method, and it would be a separate process apart from what we have here that is running our server. So let's say this is our Node.js server, and what will happen when this route one will come, we will fork a separate process. Right now this will run the expensive calculation. This will run the expensive calculation here. Uh, now let's just go to the expensive calculation here. Now let's say like once the process is over. So how we will inform our route here that the process is done? So for that, we can use this process.send method. And here, what I'm going to be doing, I will be sending an object. Let's just call it here the value, and the value would be the sum that would be calculated once this expensive calculation is over. So let's just actually wrap it inside a function. That way would make more sense. Expensive, and yeah. So let's just call the expensive method here. So when the child process would be forked, right? uh, this process.send will execute this whole method, will calculate the sum, and then it would be sending to the main process, right? This process here would be the main process that would be executing, that the Node.js server would be creating. And let's just define the event here. Let's call it expensive. Okay, now let's just go in here. So this would be forking a new process. Okay, and it would be just calculating the expensive calculation apart from our Node.js server. So once this is one process where our Node.js server is running, which is capable of handling other requests, right? And when any request that is slash route one will come, it will just create a separate process altogether and still be ready to handle other Node.js requests. Now, what will happen? Let's say once this process is calculated, once the expensive calculation is done, what will be happening? This will send a message to our main process that we can receive from child.on message. And here we would be receiving the message. And now here we can send the response to the user. So response.json, you just send some colon message. Okay, so I think it should work. Let's see if we are missing anything. Okay. Yeah, it looks good. Now let's run our application. So nodemon child process.js. So yeah, our process is started. Let's just see and if our routes are working fine. So if I hit the route 2, it works fine. And let's say if I'm hitting route 1, so it just actually calculates expensive calculation. Okay. And let's just run it here. Yeah, let's run this as well. So now this actually is working for us, but it still should take time. So we are calling expensive. It's fine. Process.send. Just increment the number a bit. I'll just hit the route 1. So route 1 is fine. Child.on message. And okay, I think it looks nice. Let's just try to hit it again. So yeah, now it is taking a time. It is doing expensive calculation in the background in the separate process. But if we still have a route 2, it's working fine. Similarly, if we hit our route 3, it still works fine. And similarly for route 4. So this is how you can create a bulletproof technique to do expensive calculations, and you can avoid blocking the event loop as well, right? So yeah, that is how it can be done, right? So that is all for this video. Thank you. Thanks for watching.